Alright, so in this video we're going to be talking about the properties of an ellipse and how to graph them. So for the formula of an ellipse, it is x minus h squared over a squared plus y minus k squared over b squared, and that equals 1. So what this is if you look at an ellipse, it's like a circle, but flatter or longer in any way. So one side, if you look at it vertically, one side would be shorter than the other, and the longer side is it correlates to A, and the shorter side correlates to B. So in this case, since if A is under x, then the horizontal side will be longer, because A is whichever side that's the longer side. And this is called the vertex, but because there's going to be there's going to be two of them from here to here, it's going to be called in its plural form vertices, and that's the longer side. So that means that B is the co-vertices, which is the shorter side. And A and B in ellipses are interchangeable. So if the graph is like this, then the A will go under the Y and the B will go under the X. What we can see here is that this distance is the sum of the distance from the center to one end and the center to another end. And because this length over here from the center to one end is A, and this distance from the center to the end is another A, the total distance between one end to another is 2A. And this is what you call the major axis. It's the major axis. And likewise, the distance from the center to the shorter end for both sides, this would be B, and this would also be B as well. So 2B would be the length of the minor axis. And one thing to point out, this is a special feature of an ellipse, is that there are 2 points inside called the foci. And these are always on the major axis, and the formula for the foci is c squared equals a squared minus b squared. What c is the distance from the center to the focus. Alright, and another thing I want to point out is how this works when you put it in ordered pairs. So the center would be h comma k. So in this case we're going to use this ellipse for this example to find the points from the center to the end of the ellipse. The vertex, that will be h plus a, and over here will be h minus a. So to find the vertex, or the vertices, because it's plural, this would be h plus or minus a over k. And likewise for the co-vertices, that is from the center to the co-vertex on both sides, that would be h comma k plus or minus b. And in this case, the co-vertices is on the y value, but over here it's going to be reversed. So the co-vertices is in the x value. And for the foci, it's on whichever side that has the major axis, or A. And because in this example, oops, my bad. A is on the x value. The foci would also be on the x value. Also, there's another thing to point out called eccentricity, and that is described by the variable e. This is the formula for this is c over a, and because the foci is inside of the ellipse, the possible E values could be from 0 to 1. And what this tells is how stretched out the ellipse is. So if the ellipse is closer to 1, that means that the foci point is really close to the vertex. And for example, that would be like, let's say that's the ellipse, and the foci points are all the way over here. Like think of these as like two poles, and the ellipse is like a rubber band around them. If the two poles are super far apart, the ellipse is going to be super stretched out, or the rubber band is going to be super stretched out. And that is when C is really close to A, and that gives a value that's really close to 1. So in the case where you get an E value that's small, that is when the foci are closer together, and that's when you get a more of a rounded type of ellipse. That is not a good drawing, but we'll just go with it. And the closer and closer the closer and closer the foci become to each other, it'll eventually just be at the same point, and that'll be a circle. Let's do an example where we graph an ellipse. So what we can see here, I'm just gonna put the original equation up here in the beginning just to make things a bit easier. It's x minus h squared So this is what it would normally look like, but as you can see in this case, the y value is greater than the x value. So instead of it being a squared underneath the b and underneath the x, it's going to be b squared underneath the x and a squared underneath the y. So what we could do is, by association, we could match the bottom. We could match the denominator of each of these functions. So y would equals b squared, and 25 would equal a squared. And I think we could, before we get to that, we could talk about the center first, because there's no mention of the h or k value here, or there's just like no number at all. That means that h is 0 and k is 0. So the center, which is h comma k, is 0 comma 0. So back to the vertices and the co-vertices. We can solve for the vertices first, for the y. So a would actually just be plus or minus 5. When we find the ordered pair for the vertex, it would just be, because this is affecting the y value, it'll be h comma k plus or minus a. So we substitute in the center, which is h comma k here, and we substitute in the distance from the vertices to the center, which is a here. So that would be 0 comma 0 plus or minus 5. That will give us 0 comma 5 and 0 comma negative 5. And we do the same here for the co-vertices. The square root of 9 would be plus or minus 3, and that would be the value for b. And because b is correlated to the x values, the x values would change. So it would be h plus or minus b comma k. And this would be 0 plus or minus 3 comma 0, 3 comma 0, and negative 3 comma 0 for the co-vertice points. Now let's take a look at the foci. So that the formula for the foci is c squared minus a squared, c squared equals a squared minus b squared. And that would be 25 minus 9, which is 16. And c would be the value of plus or minus 4. And because the foci is on the same, is going to be corresponding to the a value. This a is corresponding to the y value. Therefore, the c would be affecting the ellipsis y value, and that would be h comma k plus or minus c, which is 0, and 0 plus or minus 4. That'll give us 0 plus 4, 0 comma 4, 0 comma negative 4. And right now we have our basic structure of our ellipse. We also need to find the eccentricity. It's just another property to find. That would be C over A, which is 4 over 5. You could do plus or minus, but in terms of eccentricity, it just talks about, it's more of like an absolute value. The negative or the positive doesn't really matter. So you can just use positive to find the eccentricity, which is 0.8. And that's pretty close to 1, so we'll be expecting a pretty pretty stretched ellipse. So before we graph this, I'm going to put the co-vertices, vertices, and foci and center, all the rest of the points onto the sides so we make enough room to graph this ellipse out. So yeah. Alright, so here is our graph and the values we found at first down in the whiteboard below. So we can start with our center at 0, 0, and let's move on to our co-vertices, which is at 3, 0 and negative 3, 0. Our vertices 0, 5, 0, negative 5. And right now you could just connect the vertices to form this ellipse. And for the last points, we'll put in the foci, and that'll be over here, and that will be our ellipse.